Hello, my name is Jonathan Doyle and I'm an Applications Engineer with Dunkermotoren USA. Today we're going to be explaining how to set up one of our PI motors using our drive assistant software, which is available at www.dunkermotor.com. The drive assistant software allows connection to a range of our integrated electronics and allows us to use standard modules which can be loaded to the motors, which can then be controlled by digital inputs and outputs. The drive assistant software has 10 modules, 2 velocity modes, 2 current modes, and 6 position modes. These can be configured and downloaded to the motors. The one we're going to be demonstrating today is Complete Position Command, PI 140. The drive assistant software has a selection of different parameters that can be adjusted and then loaded to the motor. Each program has different parameters. Within the program we're using today, there are 14 distinct positions, different velocities, different accelerations, and different decelerations for each position when moving between each other. The motor can be configured whether positive is a clockwise direction or a counterclockwise direction. We can also change from absolute to relative moves. Different types of homing method. We have hard stop and also limit switch. The motor power can also be enabled or disabled after a move or after a stop command for safety reasons. We have different current limits that can be set up within the motor to prevent over torquing within the application. And we also have a quick stop ramp which allows the motor to stop faster should the command be sent from the I/O. The first thing that needs to be done when setting up a file to load to the motor is we need to select the device. We have a large list of different devices that can be configured to be used by the drive assistant software. We have our integrated electronic motors, the BG45PI, BG65PI and BG75PI. We also have a large range of motors that can be used with our external electronics, which can be also configured to work with a PI motor. So today we're going to be demonstrating a BG65PI. So I select the drive and hit Create New Settings File. We then have to create a settings file. Once we have the settings file created, what we can do is we can then change the settings which can be loaded to the motor. I'm going to change it so that we have a limit switch selected. When you're searching for a limit switch, the motor will automatically search to the limit switch and then it will back off at a much slower speed, so you get a very finite transition so that you know exactly where your home position is. So in this instance, the motor will home at a speed of 200 RPM and then will back off the home switch at 30 RPM. You can set an offset and number of counts, so if your limit switch isn't quite at the end of your travel, the offset is a certain number of counts that the home position will be away from 0. The motor won't automatically move to 0 unless commanded to do so. We're going to be working in an absolute mode. Then what I'm going to do is I'm going to alter the positions. We're going to be able to move to up to 14 distinct positions, but I'm only going to change a limited number for us to use today. We're going to do 1 revolution with a speed of 100 RPM, half a revolution with a speed of 500 RPM, 2 revolutions at a speed of 1000 RPM. I'm not going to adjust the acceleration and deceleration ramps. It can be done in exactly the same way as adjusting any of the other parameters. Now once we've set up this file, we can then click Load to Motor, and the information within this file is then sent to the motor and stored within the motor, and we no longer then need to continue to have the motor connected to the PLC. Motor is now able to be controlled using the digital inputs and outputs. The help file gives you a full description of the I/O interface in a table format, showing us which switches control which functionality and which positions you're moving to. Each of these positions in the help file corresponds to one of the 14 positions that we've actually set up within the original program. Within the position modes, the first action must always be a homing of the motor. To begin homing, we have to trigger input 1. This would then begin the homing sequence, looking for the reference switch, which is connected to input 0 of the motor. So when input 0 goes high, the motor will then slow down and back away from the limit switch until the motor's limit switch input detects no more voltage and the transition is the final home position. And as you can see from the feedback here, we're reading the temperature, the position, the velocity, the current, and the voltages. And we also show which inputs are currently high within the motor. And as you can see, the position counts have reset to 0 once the homing routine has been completed. So we now see that this is our 0 position within the motor. As you can see, position 2 is the half a revolution. And so by selecting position 2, we need input 1 and input 2 high. So by selecting those two, the motor will do half a revolution of the output shaft of the gearbox. And as you can see, it has gone to 3000 counts, which is what we set up our position on position 2. And we can make the motor rotate back the opposite direction by simply selecting position 1, which is 0 counts. Position 1 is set for input 2, so all I have to do is change input 1 low. And the motor then rotates back in the opposite direction to 0 counts. And as you can see, this can be controlled completely independently of any form of PLC, and just using 24 volt supply, signals and switches. Alternatively, you can use a I/O module on a PLC and do exactly the same thing. For more information, please see our manuals on our PI motors at dunkermotor.com, or please contact one of our representatives.